Okay, so in the last section that we covered, we talked about rational expressions. In this section, we're going to talk about rational equations. Now, with rational expressions, the first thing that we wanted to do was to get a common denominator. But with rational equations, what we want to do is we want to get rid of that. We want to get rid of that denominator, and we just want to be working with numerators. So here's how we're going to do that. I've already got x minus 3 and x plus 3 in the denominator on the left side. I have an x squared minus 9 in the denominator on the right side. So what I'm going to do is go ahead and change this to factors. And you're going to see that it's just going to be x plus 3 times x minus 3. So we get x over x minus 3 plus x over x plus 3 equals 2 over x plus 3 times x minus 3. Now, going back to algebra that we've been doing for the past couple of years, how do we get rid of something that's in the denominator? Well, we multiply it by whatever the denominator is. So since we've got an x minus 3 and x plus 3, and then an x plus 3 and x minus 3 in the denominator, we're going to multiply the entire thing by x plus 3 times x minus 3. So I'm going to put the entire thing in brackets here, and we're going to go x plus 3 times x minus 3. And what we'll do is anything that cancels out just cancels out. Anything that's left over, we multiply it against the numerator. So you can see in this first fraction, the x minus 3's would cancel out. So I want to get rid of those, but I'm left with x times x plus 3. In the second one, the x plus 3 cancels out with the x plus 3, leaving the x minus 3. So that's going to be x times x minus 3. Then, in the last fraction, both the x plus 3 and the x minus 3 cancel with the denominator, so all that's left now in that fraction is a 2. At this point, I can go ahead and distribute, and then I'll solve it from there. So x times x is x squared, x times 3 is 3x, x times x is x squared, x times negative 3 is negative 3x, and then I get equal to 2. So now I've got x squared plus x squared is 2x squared. 3x minus 3x is 0, and that's going to be equal to 2. So now I've just got ax squared is equal to c. So divide out the a value, or divide out the coefficient. So we divide out by 2. And then we've got x squared equals 1. Take the square root of both sides. So x is equal to plus or minus 1. And we can see that we don't have any restrictions of plus or minus 1 on our denominator, so both of these solutions will be correct. We're going to try another one of these in 1b. So we've got x minus 1 over x squared plus 3x plus 2, plus 2x over x plus 2 equals x minus 1 over x plus 1. So let's go ahead and factor down the denominators to make sure that we've got the lowest form that we can get to. So the factors of 2 that add to 3 are x plus 2 times x plus 1. And you can see that we've already got an x plus 2 and an x plus 1 there. So 2x over x plus 2 equals x minus 1 over x plus 1. So when we look at the least common denominator, we've got an x plus 2 and we've got an x plus 1. We've got an x plus 2 and we've got an x plus 1. So we want to multiply the entire thing by x plus 2 times x minus 1. Or x plus 1 rather. And so when we do that, we can see that this x plus 2 and this x plus 1 cancel with this x plus 2 and this x plus 1, leaving us with just the numerator of x minus 1. Plus, this x plus 2 and this x plus 2 cancel, so that's going to give us 2x times x plus 1 equals this x plus 1 and this x plus 1 cancel, so x plus 2 times x minus 1. Now we've got to go ahead and distribute and FOIL so that we can work this out. So bring down the x minus 1 plus 2x squared plus 2x equals x squared minus x plus 2x minus 2. Combine like terms, and that's going to give us x minus 1. Well, let's see, go back here real quick. We're going to go standard form and combine like terms. So 2x squared, cross that out, 2x plus x is 3x, minus this 1 equals x squared, and then we've got a negative x plus a 2x, so that's going to be positive x minus 2. Now I've got quadratics on both sides. What I'm going to do here is I'm going to move the one with the smaller coefficient over to the other side in order to get one quadratic equation. So subtract x squared from both sides, that becomes x squared over here. Subtract x from here, you get positive 2x, and then add 2 to both sides, and you get plus 1 equals 0. So now it's x squared plus 2x plus 1. This is a perfect square trinomial with x plus 1 squared equals 0. So we know that x is equal to negative 1. Now, going back and taking a look to see if our solution works, if we plug negative 1 into here, we're going to get a 0 for that factor, and 0 times that factor is going to be 0. So this solution will not work. So for this problem, there are no solutions.